So since we have two topics and both are heavy topics, and we allocated only 30 minutes, I'll let them take over from here. Igor, please introduce yourself and then walk us through the topic, please. Thank you.
Hello, everyone. Happy to talk to this board. My name is Igor Stalbikov. I'm Executive Director and Distinguished Engineer within Lenovo. My responsibility within the company is related to cloud security architecture as well as post-quantum migration. And today I'm going to cover that topic. Is fairly challenging, and we have a lot of updates happening. So I'll try to give you highlights of what's going on. You're probably watching the news, right? You're watching the news all the time and you see quantum computing. It's very quickly developing area that's going to change how we do things. And implication will be enormous. It's financial processing, AI, cybersecurity, drug design. Can you guys mute? I see a lot of sound. Weather forecasting, logistics optimization, and many other areas. This area is going to be having huge impact on everything we do. And just last year and just a few months of this year, we had numerous updates across the board. And this is introduction of new quantum chips and the new quantum computers. Google Willow chip is saying that they can solve problems that take standard supercomputer 10 septillion years. This is crazy. And same, you have Microsoft just recently released Majorana 1, first quantum processor based on topological qubits. We have massive updates in error correction technologies and qubit stability that will key issue with the quantum computers, where we had a lot of errors, and we have significant advances there. We have advances in cryptography, in algorithms, quantum algorithms that would use quantum computing unique capabilities, and this is related to quantum assist drug discovery and optimizations and other areas. So we see a lot of changes in the industry, and this is going to change the world. Now, you probably know as well that quantum computers are going to break current internet. And this is very important because whole current infrastructure based on RSA, Diffie-Hellman, ECC, and this is based on the Professor Peter Shor research on integer factorizations that would allow solve the discrete logarithm problem in polynomial time. Bad actors expecting this. They know that in few years they will be able to encrypt data that currently protected. So they're harvesting high-value sources. Many categories of sensitive information remain valuable for 25 plus years, and this take them prime target for adversaries. State-sponsored entities believe being primary drivers for that, but they're storing all the data, and whatever you send right now on the internet will be broken in few years. Cloud Security Alliance in 2022 introduced Countdown on post-quantum, and they call it year to Q, which is mean that this is year when current cryptography will be broken and all hell will be broke. We had it April 2030, but some recent estimates put it even further in 3-4 years. So it's going to be very quick transitions, and we're going to have in fairly soon, near future, a huge problem related to modern crypto. I see a lot of scary news, scary publications, crypto apocalypse, and researchers like related to Chinese research, related to recent advances, and you see this on daily basis. These expectations that urgency is growing. U.S. government didn't take this lightly, and they actually were very proactive. And we're talking about decades of efforts where federal governments put efforts on action plans and strategy, define requirements for comprehensive cryptographic inventory, recommended defenses against harvest node decrypt-related attacks, prioritized system for post-quantum transitions, focusing on high-impact information systems, high-value assets, ensuring that mission-critical data remains sensitive in long period of time are protected, and early identification of systems that not able to support post-quantum. These approximate $7.1 billion for initial transition that planned, and there is coordinated timeline in place for the transitions. All this activity is led by NIST that drive attestation of algorithms, implementing cryptographic module evaluation program, coordinated with international partners, developing partnership within industry through NIST, cybersecurity excellence program to execute migration to post-quantum cryptography. And we do also see huge appetite for quantum safe services. The active development happening right now. We have huge number of startups just the last few months in 2024, and the U.S. and EU governments dictate swift actions to ensure that industry comply. We expect that many products will start implementing post-quantum technology, like HSM vendors right now very actively working on this, with expectations to support post-quantum in this summer. As you all know, NIST start comprehensive post-quantum cryptography program, and this is program in execution for many years. Finally, in 2022, we had first round 3 completed that resulted in selection of 3 algorithms. Round 4 is in progress, and the goal to identify and develop new set of algorithms. So now we have 3 standards, final standards for Crystal Kyber, Crystal Dilithium, and Sphinx Plus. And we're going to pay most attention to first 2. Now it's called ML-CAM, ML-DSA. This will be primary candidates for replacement. These algorithms are, in addition to 2 hash-based stateful algorithms, XMSS and LMS, that were standardized in 2020, and NIST 800-208 recommended those algorithms for adoptions. These standards demonstrate high-level security. These are algorithms that have very high-level security and provide acceptable performance. They have good robustness, flexibility, and they can be applicable for multiple scenarios. The technology that used there is lattice-based, another term that you want to know, and hash-based schemas. I'm going to cover a little bit more on this in details. So let's talk about Kyber ML-CAM. This is key encapsulation schema. Traditionally, we rely on key exchange algorithm like Diffie-Hellman. Now we have to move to key encapsulation mechanism that encapsulate secrets into the ML-CAM constructs and send across. So you no longer have derivation of the secret that you have with Diffie-Hellman. There is recommendations of using this algorithm together with classical ECDHE or Diffie-Hellman algorithms. From the different levels that it's offer, we have 3 levels that provides different level of security, matching to ES128, 192, and 256. And if you take a look on the key sizes, you will see that the key sizes are fairly big. We're talking about 1,568 bytes for public key, and the secret key size is 3,168. This is much bigger than what we expected to and used to. A similar crystal dilithium, MLDSA, new name for it given by NIST. This is based again on letters-based resistance signature schema. It's based on Fiat-Shamir Vida-Bose protocol. Its strength is based on the size of matrix polynomials. It has very good speed, size advantages of hash-based schemas. And we have, again, level 5, when we're looking on the sizes, we're talking about 2,592 bytes, and signature is 5,595 bytes, way bigger than what we used to. And third algorithm is hash-based, called Sphinx Plus, and it's based on the several constructs. It's based on the Winternitz one-time signature schema. It's based on the Merkle trees and uses forest or random subsets and hypertrees. And depending from parameters, it has limitations on number of signing. So in best case, when we take in largest signatures, we're talking about limitations to its signing, how much signing it is used. This algorithm is developed for backup purposes only, and it's not actually approved for use by the government. If you look on the signature sizes, it's 49 kilobyte for the signature. It's huge. Reason why we're looking for this, because it's based on the hash-based algorithms. It's very robust, and we have very high level of confidence to its security. And LMS, XMS hash-based schemas. These were first post-quantum signing algorithms developed in 2020. And initially, they were not intended to be adopted widely, only for limited use. Again, we have use of Merkle trees and one-time hashing schemas. And the reason why we started to look on this in the last few years, because they have fairly good performance on the verification side. They don't have good performance on the signing side. And because of the long time for implementing letters-based algorithms, many companies like Intel, AMD, Microchip, they started implementing LMS and XMSS for their need. And right now we're in a situation when a major chip company only supporting LMS for post-quantum signatures. It's important to remember that these algorithms are stateful, meaning that you cannot reuse the same key. If you reuse it, you can compromise the security of entire signature scheme. Each hash-based key pair can be used only one time. Signing multiple messages with the same key would allow to recover private key. And when signing in parallel, needs synchronizations. So it's really become critical to maintain a state across signing devices which could lead to key reuse. And this has become a major issue for HSMs. We're talking to many HSM vendors, and some already have solutions, some are not. And how you synchronize the state across multiple HSMs, where HSM is supposed to be completely isolated, is still open question. And hopefully that will be resolved this year, and we'll be able to use HSM for using this algorithm for signing. Obviously, you need to have secure storage of the keys. You need to manage reboots or device failures. And number of signatures that generated is very limited. We're talking about 32,000 of signatures. Is it sufficient? Obviously, for general purpose, it is not. But in cases where you have firmware signing, for example, where you have maybe 12 or 8,000 signing during the lifetime of the firmware, is sufficient. All hash-based algorithm based on Winternet's one-time signature scheme. A very beautiful algorithm developed way long time ago. And the beauty of this is that it has very small keys and very small signature sizes, remarkably fast. And again, it's based on one time. It's one time, you sign one time and you need to dispose of the key. But in cases where you don't need to reuse keys, it provides excellent performance and excellent protection. This algorithm again mixed with Merkle trees and other type of structures to prevent key reuse. And here we have Merkle trees, and this schema has become very popular recently, used in many critical applications, and it allows sign each message with one key, validate with single keys, and reducing public key size to single hash. Obviously, that results to signature sizes being large, and obviously we need to make sure that we generate and store all the keys in advance in order to create public key. Public key essentially become a Merkle tree. So if you have to have 2 millions signing, you're going to have Merkle tree with 2 millions nodes, which could be very expensive. So again, LMS, we're looking to very limited scope, firmware signing, very quick verification is attractive, and will be used only for secure boot. We are working with many companies. We want to have MLDSA for many cases. This is not going to be an option, so we really want to be able to use best of the breed to ensure we have very quick boot time, and because of that, we're going to use mix of MLDSA and LMS for our purposes. There are other algorithms that are going to be standardized. They are approved for standardizations, and I'm going to cover them very quickly because we do not expect to use them. And Vulkan has very good parameters, but it requires floating point calculations, and there is a side channel attacks related to floating point rounding inconsistencies. So that's a big issue that's not yet resolved. It probably will be standardized fairly soon. Still, we're not planning to use this algorithm for our purposes. Another one that was just approved a few days ago called HQC. This was developed as backup for MLCam, for key encapsulations. In case of MLCam is broken, they're looking to use this one. Hopefully that will not never happen and we will never have to use this algorithm. It has much bigger key sizes. Now we're talking about fairly large key sizes, like 31,000 bits to ensure 256 bit security. So it's really big and is not suitable for many applications. Now let's talk about standards. Commercial national security algorithms suite. It provides updates to the standards, and it has a very important information related to algorithms, parameters, timelines, and testing requirements. So if you're looking to implement post-quantum, this is one of the guiding documents for you. If you look on these algorithms, you will see that it's only supporting category 5 for MLCam, only category 5 for MLDSA. And our traditional algorithms like ECC, RSA, they're all no longer allowed. They can be used as a hybrid. Also, Sphinx Plus is not part of the suite and not approved for government applications. Highest priority is given to firmware signing and hardware root of trust, and this would drive LMS adoption. And this is timeline. You can see the timeline is very, very, very tight. And the firmware and software signing is the highest priority at this point, especially when you need to deal with hardware. We are not changing hardware every day, and the cost of replacement hardware very high. Putting post-quantum resistant hardware root of trust is critical. This is why it's highest priority. Web browser service, cloud services, all of that would follow the suit. Operating system, traditional network equipment, all of that would follow. So we expect massive transition to post-quantum 2026, 2027, etc. So this is areas where priorities are. When we're looking for international standards, and as you may anticipate, European government organizations, Japan, China, Australia, all other countries looking for that. And we see some massive adoption of NIST recommended algorithms. In the same time, we see disconnect. And again, we have this is our CNSA 2.0, but UK and CSC is prefer level 3. NIST recommends has shake, not allowed by CNSA. Sphinx Plus is not allowed. Similar for Falcon and HKC. Germany, we have new algorithm for the CAM, not standardized. Classic MAC list, not standardized by NIST. And again, hybrid schemas are allowed. China started to develop its own set of algorithms, and they started to solicit proposals. We'll see where it will go. NIST provided recommended migration.
Igor, you have 6 more minutes.
So thank you for reminding me, and I will try to be quick. Please take time, look on those risk assessments and inventory of cryptographic assets, ensure compliance to standards, crypto agility, collaboration and knowledge sharing, testing, all of that is important. And when we're talking about challenges, look ahead and look on the challenges that we have. Large key sizes, large memory consumption, that causing hardware vendors like Lenovo increase memory sizes to allow those algorithms to operate. Compatibility and integration issues, very big. Delays in standardization. We still don't have many standards required, like X509 and TLS standards are very critical. We don't have standardization of those. We have a lot of dependencies on our supply chain. We have issues with algorithm not being well tested as we expected. We have huge complexity. We have key management. A lot of those items are in place. So transition will be very challenging, and you need to be ready. Think about crypto agility, because this would be driving factors for you. You need to make sure that you be able to support multiple cryptographic algorithms and swiftly move from one to another. And you need to be able to switch libraries, support hybrid schemas, able to support two schemas at the same time, like classical and regular one, and be able to migrate to new things. So there's a lot of data. I'm closing my presentations, and I was thinking that I'm going to have whole 1 hour. Apparently, there's a lot of interesting material coming in for you guys. Please take a look, pay attention to it. This is changing the industry, and you need to be aware about it.
Okay. Thanks, Igor. Are there any questions? We still have 4 more minutes for this topic. If there are any questions, please unmute yourself or type it on the chat. Otherwise, obviously the slide deck will be uploaded along with the recording onto the LinkedIn group tomorrow.
Is it okay to just speak up questions?
Yes, please do.
I want to go back to square one when we were briefly referring to Google supremacy around Sycamore and Willow. I didn't find any, facts on the number of qubits coming with this future Willow quantum chip there, and I remember the 2019 context where they had this optimized mathematical problem, which is not like, for real life applications, not suitable for those, which led to a lot of discussion. So I'm wondering how hard the properties of that not yet really well-known chip will be. Could you elaborate a little bit on that?
So in regards of qubits, I don't want to give you information. It was a long time I looked into it. It was fairly small. I think it's less than 100, maybe 100 to 8. I may be wrong there. There's so much data coming up every day. So what happened in November is already old news. So I may be wrong there. So number of qubits is still fairly small. The fact that they're able to put qubits into the chip is the key thing. Now to your question on algorithm used. When they had the first testing on with those quantum computers, they intentionally selected area that not a little bit theoretical, and Google was criticized for that because they will try to solve the problem that may not be as practical. I do saw multiple publications actually on trying quantum computers on practical areas, and in fact, we had Chinese publications on breaking RSA with quantum computers, testing those algorithms, and they were successful. Obviously, they were using much smaller key sizes, fairly small key sizes. So it does mean that we have broken RSA right now. It just means that those algorithms are practical. I might have to give you another presentation just to cover that topic, because this is a lot of things happening. And if you look on this, let me go back to this slide. I actually listed some of the algorithms, and they were tested. I'm going to this. So you have quantum assisted drug discovery, drug approximate optimization algorithms, and variational quantum engine resolver. I'm not expert on these algorithms, so I'm probably the wrong person to even comment on those algorithms. I know there's a lot of work happening in quantum machine learning, and this is called near quantum AI. And this expectation that in a few years we're going to have huge advances in this area. This will be next area where AI and quantum will merge and be able to produce new results that are amazing.
How much of this is research results, and how much has been deployed on existing
it's probably just research for now.
Yes, that's what I assumed.
It is a research, and remember, we just have those chips. It's not even available for anybody to use. So you have research with anticipation. We have quantum computers. The fact that this is just research, it doesn't mean that we should not pay attention to it. It means that we need to actually pay attention how this is happening, but we don't have immediate today threat. We're going to have a threat in a few years.
Okay, thanks, Igor. Thanks, Saints, for for that question and to initiate the discussion. So we are about halftime, and I would like to thank Igor and for a great presentation, and hand over to Vinay for his next topic. Vinay, please take it over.
Can you hear me?
Yeah, we can hear you.
Great presentation, Igor. It's a dense subject, huh? So hopefully this one is not as dense as Igor is, right? So people can feel a little lighter. So, okay, so I'm sharing my slide. I just want to make sure.
I can see your slide, Vinay. Just run it in the presenter mode or whatever, however you want it.
Okay. Yeah, okay.
Briefly introduce yourself and go ahead with the presentation.
Okay, good. Thank you. Okay, welcome everyone again, right? So, as you probably know, my name is Vinay Bansal, and many of you may have seen me in the CSA Triangle chapters, right? So currently I'm on board as a training director. My job, what I do for getting money, right, is part of Cisco. So I'm part of the Cisco incident response team, being a CTO and principal engineer for the team. Another area, along with participating on CSA as a training director, I also have been participating in something called COSAI, which is Coalition for Secure AI. And that's what I want to talk about, right? So my goal for today is to introduce what exactly is this Coalition for Secure AI, what kind of things it is doing. And I know discussing or talking with many of you means AI is in every discussion nowadays, right? So many of you want to call it build more skills, be participating more on the AI. I want to kind of share with you what's happening in the COSAI and where you can either leverage some of the work being produced as part of the COSAI, or if you want to participate in the COSAI, right, what you need to be doing. So that's going to be my goal for today's presentation, to go over that. So let me start over, like, what exactly will be the agenda. Like what I said, what is COSAI? There are 4 work streams, right, currently as part of the COSAI. And then I'll go over them, right? And there's one of the work stream, which is a Defender work stream, which I'm leading for the COSAI. So I'll go a little bit in more detail on that particular work stream. What are some of the key findings and proposed standards? So COSAI is part of the OSS, right? So that's a standards body. So you will see that a lot of our focus is to look at that landscape of what's happening on the AI and proposing certain standards, right? And I'll share with you, right, what are some of those things which we are doing, and how can you participate, right? That to me should be one of the bigger outcome. If some of you want to participate, I'll love to see you, right, participating uh, in kind of creating some of those standards, creating some of the artifacts which we are planning for the COSAI. So what exactly is the Coalition for Secure AI, right? And what I can do is, just to keep it interactive, I'm going to see if I can post this links there, right? So if some of you want to follow along, um,
Yeah, I
I'm
love
going.
it. Listen to this too.
Yeah. I'm getting some backgrounds. Okay, now it's gone. So yeah, so there's a link, right? So you can actually follow. So this is a Coalition for Secure AI, right? So the how is it different than others, right? It's actually, we have around 40 companies who have come together, right? So it's starting from the big ones in AI, like the OpenAI, Google, Microsoft, right? Cisco, Palo Alto, NVIDIA. We have participations from around 40 companies, right? So what it means is, like, we have mainly some of the fellows, some of the distinguished and principal engineers who are participating from that companies to create, like, how we can collaborate together, right, to create a secure AI standards, right, what is needed to figure it out, what are the gaps. Now, it doesn't mean that you need to be part of these 40 companies to be participating in it, right? So you could go independent, right, to participate. And there are some links I'll give you, right? And if you have any issues, you can just ping me on the side, right, if you want to be participating, especially in defining some of these standards. Definitely, it's kind of open source. You can all leverage what is being produced there, right? And I will show you how to do that. So what exactly, going back to the, so it's ecosystem of AI and security experts from industry leading organizations, right? So it's both AI and security focused, right? There's kind of, the security is one, which I'm kind of, the reason I'm participating in it, and many of you may feel kind of, okay, what exactly it's bringing, and sharing best practices from AI deployment. So a lot of these things which we are doing, how these enterprises, big companies can securely deploy, how they can work on leveraging AI within their enterprises. Now, jumping into what are the different work streams which we have as part of the COSAI. So there are 4 work streams currently, right? So and those were kind of identified as part of, okay, what we think enterprises are, call it, lacking or need to be doing well, right, to have secure AI usage across. One is obviously the AI supply chain security, right? So looking at like from where are you getting your models, from where are you getting your chips, where are your things running, who are your suppliers of your AI, and it goes into, and I'll go a little bit deeper into each of these work stream, right, and talk about what's happening there. So second one, right, which I'm currently leading is preparing defenders of AI. That's the area where we are trying to look into, okay, defenders, the people who are security practitioners within the enterprises, how they need to be working so that they can defend, they can securely make the usage of AI across their enterprises or where they're working. And the governance goes into looking at various regulations, various things coming from standards, and how we comply to that, how we try to take it, right, and understand that, and how we can apply it. And there's a new work stream which we are actually just kicking it off, right, which is on the agentic AI security. So I think you must have heard, right, the agentic is picking up so quickly with the AI becoming agentic. That means AI is doing much more than just those chatbots, right? It's doing executing commands for you, doing stuff for you, right? So we are starting to look into what exactly will be our standards and security around the agentic side of the AI. So those are the four work streams, right? So I gave you a link, right? So you can start going through, okay, what are the different work streams? So again, this was kicked off like almost 6 months back, right? And the real work started in last 3 to 4 months, right? So it's something new, right? So a lot of opportunity for number of you if you want to participate, but and we are actually publishing at least two of our what we call landscaping papers, and I'll kind of share with you and show you what's happening there, right? And that will get published in the RSA, and in the RSA, I think is it next month, right? In the RSA. So I'll go over the first one, right? To again, this is not going to be a comprehensive presentation on each of the work stream, right? I just want to introduce you, right, and try to see what's happening there. So first one, right, going deeper into the securing software supply chain of AI is definitely looking into from the AI perspective. When you think of the supply chain, what does it mean, right? So when we are using a model, we could be getting a model from a third party. We could be picking up from Hugging Face, or we could be picking up a model from another company, right? Like you can use OpenAI's model or Google's model. So who becomes your supplier? Are you doing your fine tuning of those models? Then you may be running those models within your own data center, or are you running on a cloud environment or at a third party, right? Or you could be using just the APIs of those models. So understanding what exactly your supply chain becomes for the AI usage. Now, along with the actual model, there's all those things of the data also that comes and plays in that. If someone, a supplier, has built a model for you, from where they got the data, what kind of data, what kind of training they did, right, what kind of versioning they have, all those kind of things which needs to be tackled properly from the supply chain perspective. So that's what this particular work stream is doing. I'm going to actually share, just jump between showing you, because my whole goal here is to excite you to participate in it, right? So if you actually look into the work stream 2, right, or work stream 1, which is the supply chain, right? So what is being happening? This is actually the currently drafted paper, which is going to get released in a couple of weeks, right? So this is where we are going into and trying to look into from the supply chain perspective, figuring it out what kind of supply chain attacks can happen with the AI, what are the threats, and then coming up with the different guidelines. Now, another thing which is happening here is out of all this work, there are these work streams, sub-work streams which are coming, because as we are doing this work, we're identifying there's a need to how we sign our models, how we have cards. Cards are like ways for us to specify the model, the security aspects for a model, how those could be shared, how those could be standardized. Those are sub work streams which are getting identified, right? And that's looking for more participation and more usage. So you can use it in two ways, right? Either, and I already gave you the links, right? So one of the good things for me participating in and building it, a lot of this work is on GitHub, right? Even the documents. So you can go and get it as well as put comments, right? Or if you become a formal participant, you can be even writing some of these documents or updating those, right? I'm just going to give you a glimpse of it, right? So this one is focused on the supply chain. So it's looking at from the supply chain perspective, right? And the threats as well as what is needed from the supply chain. We are currently doing what we call our landscaping paper. So we are surveying the whole area, trying to look for what are the gaps existing, right? Where the COSI can lead in and build standards or guidelines for the different organizations to use. I'm going to switch back to, so this was one of the first work stream, right? So it's definitely coming up with what are the risks, model threats. Again, I'm not going to go into detail of that, right? Because that each of these work stream has so many people working on it, right? And you can always go through the actual document. I'll go to the next work stream, right? Actually, which is the work stream 2. I marked it wrong here. So preparing defenders for AI systems. So this is the work stream, right, which I'm currently leading.
Vinay,
So we are.
Vinay, there was a comment to switch to presentation mode.
Oh, is it okay?
Still planning to switch back and forth.
Okay. I was, but yeah, I can go into this. So this is the second work stream, right, which is preparing defenders of AI systems. The goal of this work stream is to look into how we prepare our defenders. Now, as I said, right, since we recently started, our first thing is to survey what exactly is there, right? So there's already a number of work being done by OWASP from NIST and other places, right? So we are surveying that and trying to look for what exists, what are the gaps in some of those guidelines, and what we could be doing next, right, out of all that work. So I'll just jump into this, right? So this is one thing which and there's a whole landscaping paper, and I'll show you, right? I'll show you the link. There's a link actually in the presentation also, but I'll show you. So we actually surveyed all these different standards, right, across what is there related to the AI, which applies to the defender side of mindset. So you see things like the MITRE attack, MITRE defend, right, and looking into the zero trust aspects of things, as well as looking into what OWASP has produced in terms of the top 10 LLMs, right, and NIST AI standards. And then one of the things which we did as part of it, because there's a lot of these standards, we tried to actually also look into which of these will be applicable to what target audience, right? So that's just one part. Again, I'm sharing you a few kind of interesting things, right, which we are putting together in the landscaping paper, but that's not the end, right? That's probably the starting to look into, okay, where will they be applying? For example, if you're an IT architect, what are the frameworks that are most closer to you, right? Or if you are a CSO or the executive, what are the frameworks, right, which are going to be closest to you? Or if you're a data scientist, which are more appropriate frameworks, which are existing frameworks, which you could be referring to. Now, we also looked into what are the different gaps available, or what are the different gaps, because we did there's a 170-page survey which was done. Again, I'm going to switch to the GitHub here, right? So you see this is our 170-page survey on all the different. We looked into all the existing standards, right, or existing stuff available from MITRE and Atlas, right? And then we compared it against, okay, what is needed from a defender perspective, right? And looked into what are the different gaps existing for those, right? So again, I won't be able to go through the whole paper, right? You can always refer to it, right? There are links to the actual things, right? So we looked into, right, and then we also mapped into what is needed, right, from different perspective. But the crux of it, right, which is coming up, these are the high level gaps, right? Threat model for AI. How do we do a threat modeling for AI? That's one gap, right? And for each of these gaps, we are starting again this sub work streams, which is getting kicked off, right? We are kind of, there's a sub work stream on what's our framework for threat modeling for AI? How do we kind of teach, right? Because for example, just going into that one thing, right? So threat model, what we are seeing is there's so many different patterns of AI usage. It's not just one threat model that will work, right? Companies can be embedding AI into their systems. They may have a chatbot kind of functionalities for their system. They may be using some of the models which are hosted in the cloud or in their own data centers. They may be fine-tuning an existing model, or they may be just taking a model and using it, a LLM model, right? So there's so many permutation combinations, and what is missing here is, can we give a guidance to the defenders how they do a threat model, proper threat model for these 8, 10, or n number of different scenarios. Similarly, incident response, right? So how does the incident responders, if there's an AI-based incident, what exactly they need to be doing differently than what they do, right? So there's a NIST standard on the cybersecurity for the incident responders, but that is lacking some guidance, right? So along with, we talked about AI supply chain, right? And few other areas, which is the gaps which we identified out of it. So again, you can go through there's a link to these papers, right? If you're interested, this is the whole 107 pages document, right? Which goes through looking at the defender. But the next step is interesting for us, right? Because now we are going into the next step where we are taking those gaps and starting new work streams to work on, right? More specific, um, I wouldn't say papers, but more specific artifacts. Those artifacts could be a standards being released, or a set of code being released, right, as part of this work. The third work stream, right? So I'll quickly go over to the third work stream, which is on AI risk governance, right? It's looking into what governance means for the AI, right? What are the different again, it's at this point we are starting with the landscaping work, right? So you can always refer to that landscaping work. Some of us, right, who are working on this work stream have looked into, it's kind of all the body of existing frameworks and regulations related to governance, and you see different governments starting from White House to UK to European bodies to Canada to Australia to Japan. So we're trying to look into, okay, surveying all of them and putting them together and figuring it out, what does that mean, right? What it collectively means to, right? And what are some of the potential, call it, gaps or opportunities there, right? So this is a third work stream, which is still some work in the progress. So there's a whole document again, right? Like I said, there is a landscaping work being done to look at these regulations and coming up with gaps and coming up with what are the different opportunities for, right? And this will not get, this one won't be published, right? The only two which will get published is in the Apple, but they're available, right, as a draft on the websites which I am giving you, right? So you can look at what's the work in progress. As I said, there's a fourth work stream, right, which is on the agentic AI, which just is getting kicked off, right? Given the whole goal for this work stream is to develop the secure design patterns for AI agentic use, right? And then looking into various areas, right? What's the agentic frameworks, right? What are the, again, threat models? That's especially if you put a defender hat, right? You always go into understanding what exactly is the threat model for that given use, and what would be some of the secure design patterns that will come out. So there is an opportunity to be part of this particular work stream, because it is getting kicked off and looking for more contributors to be part of it. Here are some kind of just to here is how you can participate, right? So I already shared with you the COSAI's open project page, right? So I'll bring it again back here. So you have like this is the COSAI website, right, which is part of the OSS, as I said. The more interesting part or the meat of things are in the GitHub, right? So posted the GitHub link, right, where you will have all those work streams, and each of those work streams will in turn have their own projects or sub things, right? And that's where a lot of the collaboration happens. If I have to show you something, right? And then again, this is an opportunity. It was good for me to, I haven't collaborated on a GitHub myself for a document. I've done it in the Google Drive. Generally, we are trying to do a mixture of initial cut on the Google Drive and then using the GitHub to get comments, right, and other things on these documents. So it's a good opportunity, right, for some of you who haven't done that, right? So see me as one of the leads for this whole work stream. And then we do all these merge requests, right? And the commenters will create issues in terms of if they want to add something. So there's some good opportunities, right, which to participate and look at the content. You can monitor and observe, right? As I'm saying, if you just want to use some of the content being produced, or you can actively contribute, right? And then joining the leadership team, right? That requires generally kind of to be on the voting member or some of those things. Definitely, you may have to go through some of the companies. I'm not sure of all the rules we can check if you want to join. On the leadership team, definitely we have number of participants who are independent, right? Generally, the companies who are participating that get some special privilege on voting on some standards and documents, right, as they are being published. So I'm going to stop there. I know it's 53, so we have 7 minutes to see if anyone has questions.
Sachin, you asked a question about the links to participate. Was that answered?
So I see it here, but it's not clickable, right? At
Yeah,
our end.
we'll send the slide. We'll upload the slides onto the LinkedIn
I
group.
see.
Yeah.
Okay, that will help as well. Otherwise, I was wondering if we can share it in the chat here. We can click on it and start taking a look. But we'll wait
Okay, I
for the
mean,
slides.
I clicked on it. I mean, let me do it right now. And so,
That's all right.
okay.
We'll wait for the slides then. If they're clickable, we'll take it from there.
Find the GitHub repository easily, and then you can click from there also, which is what I did.
You went there manually, is it? With the GitHub? I
Yeah,
didn't
I
find
went to GitHub, searching for it, DuckDuckGo or whatever, and then you find the
Oh, I
reference.
see. Okay.
Yeah.
I posted the link also in case you're kind of interested.
Yeah, I see that, Vinay. Thanks.
Okay. Yeah, hopefully my whole goal here was to make you aware of this effort as well as motivate you to participate. Right? So, more questions or comments?
Yeah, as this is the Coalition for Secure AI, I was wondering, as the various bodies such as the European Union and United Nations and all the rest on the list there, OECD and whoever, is already involved in coming up with recommendations, ethical ones and whatnot. Do you have stakeholders from these bodies already, on the team?
So there is slowly. So we started with these big, call it, companies, right? So it started more on the commercial sides, right? But we have been actually partnering with. There is for example, in my Defender workstream, there is some participation with some of the uh, individuals who are part of the European, some of the standards on AI, right? So we are slowly getting those participations, right, with those individuals participating in it, looking at the development of it, right? So that's what we kind of expect, and especially on the OWASP, right? We have a participation now with the OWASP top 10 LLM, that body of work, right? We have some collaboration going on there. So since it's new, it started with all these companies, but we are seeing, back to your question on with those other agencies or government bodies, right, participation picking up.
But this is an ongoing aim, basically, to get them onboarded, right, as, holding their stake in this coalition.
Yeah.
Okay.
Good point, yeah.
Yeah, different question. Looking at your, I think it's 5 major goals on your manifesto. I was wondering, many of those have already been silently touched on with the introduction of the longer list of publicly accessible models, like pick ChatGPT as the general purpose LLM and whatnot. So things like the human AI interaction and the resulting impacts on decision making, they have been touched on before you probably started to, think about them in an organized and collaborative way. I was wondering about the friction resulting from that and how much experience originates from that to your collaboration.
So one of the things, the reason we did the whole gap analysis for the landscaping papers is for this whole reason into figuring it out what are the existing standards, existing frameworks already being released, right? Different bodies, and where are the gaps. So our whole goal is we don't want to duplicate any of the work, right? If those things exist today, right, we want to probably recognize it, even in a lot of the papers, right? So if I want to just go into one of them, right, I'm closest to the work I've been leading, right, which is on the defender side of things. So we didn't start with, okay, let's start from zero, how we do it, right? Our whole thing was the deep dive into existing frameworks, right? So we looked into, okay, what NIST is giving, what's the kind of personas being addressed by it, right? And this is kind of, we broke it down into few individuals looking into that standard, right? And what kind of guidance is being provided, right? And then we looked into where are some of those gaps. So our whole goal, right, with, and especially since we have around 40 companies, right, and probably very talented people, some of them are fellows and distinguished engineers in their companies are participating in doing it. The whole goal is, right, we can work on the things which are the collective gaps, right, which exist, where we can help what we call defenders or practitioners within the various enterprises.
Yeah, right. This is like the classic of analyzing existing art IP implications and respective gaps, which is very important and I respect it. I was more about like, there has been a developing culture already. So people are using that. Groups are forming around utilization of, Google products, OpenAI products, you name it. And this has also severe like cultural and practical implications. Do you have an eye on those too?
Okay, I'm still trying to understand your question. So the way I
Yeah, people
Mhm,
already used it like 2 years
mhm,
ago, starting 2 years ago, publicly
mhm,
accessible model service to the on the internet essentially, and that changes their way of working and learning and decision making. So there's a cultural change involved, and that
mhm,
has impact on any solutions missing, whatever the works.
mhm.
I
Yeah.
was
So
taking
I'll
a look
pick
at
you
that.
if yeah, I'll give you two examples, right, which is probably closer to my participation. For example, I see that even within the coalition members, right, we see that there is from the investigation and incident response, what exactly an investigator need, what kind of monitoring logs which we need, right, for these AI systems. That thing is not very well defined, right? So there may be some people doing it one way or the other, right? But then there's a big gap, right, on okay, what should be the standard? What kind of logs which we require from these systems? When an incident happens, right, how do we do the incident response on it? What's our mitigations? All those things are gap. Now, some people may obviously have tried doing it in one way or the other, right? But we see there's a lack of standardization, lack of the guidance on those things, right? And that's what we are trying to address, right? How we can provide a guidance which could be given and leveraged by many, right, across. That's how we are seeing it. Again, I know that we are out of time, right? I'll give it back to Shankar. So we are
Yeah.
recording this and I'll share this slide and feel free to, I'm definitely passionate about this, right? Feel free to reach back to me, right? If you are interested to know more.
Hence, thank you. Look, you guys can take it offline for sure, but thanks for your questions and discussion and participation. Uh, as as we ran out of time, I would like to close it out. And as I said, we'll post the recording on our LinkedIn group and send the message on the CSA Triangle chapter social media sites and upload the slides as well. And if there are any questions, please reach out to me so that I can pass down to the speakers. Again, Igor and Vinay, thanks a lot for your presentations. Great topics, great discussion. Obviously, there's a lot more to cover in 30 minutes on each of these topics, but you guys did great. Thank you.